And welcome to today's cosmology segment. I'm your host, Dan, aka smAsho. And we are streaming live to Twitch, where this was originally created. Twitch.tv/smAsho is the URL. By the way, we're also on BitChute, if you're not aware. Check us out over there. The climate videos and meteorology segments are quite a hit. And if you're only viewing the video elsewhere, make sure you view us on YouTube as well. YouTube.com/smAsho. Today's cosmology segment has got some fascinating stories once again, which is why we made it into a separate video. And make sure you check out our playlists if you haven't. YouTube.com/smAsho/playlists. Starting out today's cosmology segment with magnetic fields implicated in the mysterious midlife crisis of stars. Is the sun going to murder us? Well, probably not. And a lot of alarmist YouTube channels would prefer this to be correct. However, the main problem with certain alarmist YouTube channels is that they have no idea the physics of how the sun works, and they're using a weird combination of mainstream astronomy with the concordance model to try to support their ridiculous theories about how the sun's going to explode and destroy all life on Earth. So it's talking about the Maunder minimum here, and let me just read this paragraph for you here. This hypothesis of subcritical magnetic dynamos of solar-like stars provides a self-consistent unifying physical basis for a diversity of solar stellar phenomenon, such as why stars beyond their midlife do not spin down as fast in their youth, the breakdown of stellar gyrochronology relations, and recent findings suggesting that the sun may be transitioning to a magnetically inactive future. So there's some alarmism for you. The problem is that this model does not understand the mechanism behind the solar polar field reversal cycles, which, again, we'll explain soon on the channel, as the theory is fully hashed out now and provides what I would consider a working model of the sun. One of the things that we are aware of, folks, is that stellar activity and rotation rate are absolutely related. So there is a proportional relationship between stellar rotations and their magnetic field strength. I'm going to leave that there. This article is from the phys.org Astronomy and Space section. And the title, Magnetic Fields Implicated in Mysterious Midlife Crisis of Stars. Also, there is an issue with the concordance model regarding stellar life cycles. I don't want to get too in-depth into that in today's cosmology segment. And I've been studying stellar cosmology in serious depth since the mid-90s. And I've been studying cosmic rays since about 1980. So let's talk about a more reasonable model of stars, that they're made of superionized materials, condensed matter. In the sun's case, liquid metallic hydrogen. Probably all stars, but in any case, this imagery you're seeing right here is another superionized material. So we've talked many times on the channel about superionized hydrogen, superionized water, which forms into a lattice structure. Well, this is magnesium sulfide. So those purple circles there, those are magnesium, and those hourglass-shaped things, those are disulfide. And when you put this under about 400,000 psi, you get this lattice structure where the materials become superionized. Now, we can only do this with very small amounts of material in an object called a diamond anvil, which is literally two diamonds that you're just pressing together using a vise-like instrument. And the diamonds have a groove in them, and that allows us to put a tiny amount of gas, and then we shine a laser through there, and we're able to observe what happens under these high pressures. This is probably what's going on inside of stars and planets, superionized materials. It explains why there's so much hydrogen in space. And it explains all kinds of other things, like the idea that the intrinsic properties of stars explains all of their behavior. So when it comes to cosmology, and when it comes to material science, superionized materials are where it's at. Here's another great experiment on superionized magnesium sulfide. So this article is on SciTech Daily. And we're talking about approximately 435 psi to achieve this superionized state. And it all has to do with the way the electrons line up and the way it behaves like a metal. The interesting thing about magnesium sulfide in a superionized state is that it goes from an insulator state to a metallic state and then back to an insulator state at a higher pressure. The title of this article is Remarkable Things Happen When a quote squishy and quote compound is compressed. Let's talk about galactic cores moving out to a massive scale. These objects are galaxies. So we're looking at probably like 1 million light years. This is probably like 1 million light years, something like that. If those galaxies are similar in size to the Milky Way galaxy, that would be about right. And this is called Abell 1775. So this is a galactic cluster which has been observed in unprecedented detail. And before I continue, just let me check the life of the stream here, which looks like it is doing just fine. So Abell 1775 has this massive jet, and I actually forecasted that we would start seeing jets of this scale. That's like a 1 million light year long jet. And yeah, massive radio filaments coming out of this galactic pair. It looks like a galactic merger going on. And this is one of the largest objects in the universe if you're defining objects as gravitationally bound ones. So let's just zoom all the way into this here to show the insane detail. And you're looking at multiple different wavelengths here. This is actually radio and X-ray. And I'll just let the article scroll here. As those galactic jets are quite significant, let's play in some imagery here. We'll make sure we mute that. And these jets aren't fully understood. However, they are a source of what we would call cosmic rays. And cosmic rays, like the solar wind, are made of primarily hydrogen nuclei, otherwise known as solar protons, or in this case stellar protons, since they're not coming from the sun. But in any case, there's some more imagery of Abell 1775. And it's quite distant here, located about 960 million light years from Earth. Not something expected to be in any way gravitationally related to the Milky Way / Andromeda galaxy cluster area, the local group. And I'll just let the article scroll here. Feel free to pause the video if you want to read the article. Again, this is on scitechdaily.com. Non-thermal phenomenon. Revived fossil plasma and slingshot radio halo. They definitely beefed up their terminology for this one. Galaxy Abell 1775. So here it is. This is on the Pan-STARRS, actually. This is in optical bands. And let's check it out in ultraviolet. That should give you some insight into the plasma structures, which are quite irregularly shaped, as there is probably a galactic merger going on. Those galaxies are very close, and their jets are pointed in an odd direction. It looks like it's sort of almost parallel to the galactic disk. And here it is on the 2-mass in infrared spectra. The thermal emissions from Galaxy Abell 1775. Next, let's take a look at the astronomy picture of the day. This is the Saturnian moon Mimas. And check out the lumpy, fantastic detail here. I don't remember what this was from. Was it from Cassini? It was from Cassini back in 2017. And there's also a composite image if you hover over this. It's at apod.nasa.gov if you want to look at it yourself. apod.nasa.gov. We've got the fully lit image as well. Quite a lumpy moon there. The Saturnian synchronized moon of Mimas is the astronomy picture of the day. By the way, here are the X-ray outputs of the core of the Milky Way galaxy, if you're wondering. That's Sagittarius A star. And if you want to look that up on the Neil Gehrels Swift Bat X-ray Observatory, just hit Control F and type in SGR space A. It's entry number 705. Sagittarius A star, the supermassive radio source at the core of the Milky Way galaxy. Next, the Andromeda galaxy. Shown in unprecedented radio detail, check out this crazy ring feature around it. And if you follow us on Entropy Busters Facebook group, facebook.com/groups/Entropy Busters, we actually have a thing similar to this on the as the cover image for Entropy Busters and for the default profile image for Entropy Busters. There's this ring-like feature around the core of the Andromeda galaxy, which has now been observed in radio. There's a group of stars that are being slingshotted out of the galactic core region. It's a very different galactic core to the structure of the Milky Way galaxy's core. Here's what the Milky Way galaxy's core looks like. That is what's going on around Sagittarius A star. Totally different than what's going on around Andromeda. Andromeda is a much more orderly system where the stars are largely orbiting on one plane, not chaotically in these three-dimensionally disturbed orbits, these extremely eccentric orbits like we see at the core of the Milky Way. This article from phys.org as well. And we see special features looking at 6.6 gigahertz microwave frequency. So that's basically what the article's about. I figured I'd cover it. Also, one more thing, a new X-ray scanner set to launch. Thank goodness. We need a new X-ray imager. It's going to be awesome. The Incidence X-ray Spectrometer, or MAGX. It's MAGX. So it's going to launch today. The launch window opens today, so we're stoked about this. Can't wait to see some new X-ray imagery. That's today's Cosmology segment. Thanks for tuning in. Remember to press like and subscribe if you enjoy the content. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network. Least busted. Naming news.